Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 260, and today is our lesson number 170. Lesson number 170, problem number 8. Problem number 8. Now on the blackboard what you see there is the work that we did yesterday, and I haven't erased it because we're going to need the same work today, the same concept today and tomorrow. Question number 8, 9 and 10, or rather, I'm sorry, question number 7, 8 and 9 deal with the same concept, the concept being similar triangles. What does it mean for two triangles to be similar? For example, here's the triangle here. Let's draw two triangles. We're going to draw two similar triangles. This is 30 degrees, and I'm telling you that this is 30 degrees. Okay, you're being told that this is 30 degrees, this is 30 degrees. Let's say that this is 80 degrees, and this is 80 degrees. So that's 110, so this must be 70. This is 70 degrees, and this is 70 degrees. As you can see, these triangles are of different sizes, but two triangles are said to be similar. Two triangles are said to be similar. Let's call them PQR, and you see, since I started P on the top, this guy has to be the first letter, which is X. In other words, I can't go X, Y, Z. It has to be X, they have to correspond. P is on the top, X has to be on the top, X, Y has to be on the left, because Q is on the left, X, Y, Z. They have to correspond. So, what does it mean for two triangles to be similar? What does it mean for two triangles to be similar? Well, the two triangles are said to be similar if all the corresponding angles, of the two triangles are equal to each other, as we see here. This is 30, this is 30. That one is 70, that one is 70. This is 80 and that's 80. All the corresponding angles are equal. That's the first condition. And the second condition is if the length of the two triangles are proportional. Actually, one implies the other. One implies the other. If this is true, then that one's true. One implies the other. So if the sides are proportional, if you have two triangles where the corresponding sides are proportional, in other words, for example, if this is 10 and this is 30, you see 3 times as much, and if this is 3, this is 9, and if this is 7 and this is 21, I'm not sure if this is actually that is not a correct triangle. Can you tell me why? This is an interesting digression here. We'll come to that in a second. This is not a legitimate triangle. We'll come to that in a second. But it is corresponding. You see, it is proportional. This side is 10, this is 30, this is 3, this is 9, 3 times 3, and that's 7, that's 21. So, if the length of the two triangles are proportional, then the interior angles are going to be corresponding angles are going to be equal. If the interior corresponding angles are equal, the length are going to be proportional. One implies the other. But that's what it means. Now let's finish it up. Since I made a boo-boo here, we have to finish it up. Why is this triangle not legitimate? Why is this triangle not legitimate? Because in a triangle, the sum of two sides always has to be more than the third side. Sum of two sides in any triangle is always more than the third side. This is not a legitimate triangle. This is a nonsense. This is a nonsense. I have to fix it somehow. What I'm trying to tell you is this. What I'm trying to tell you is that if I live in town X, listen carefully, if I live in town X, what I'm telling you is that I can go from town X to town Y directly, and if I did that, I'll end up driving 30 miles. But if I make a detour, if I first make a stop at Z and then come over here, I'll still drive 30 miles. That's not possible. Sum of these two sides has to be more than this side. So let's change that to 20. since we're doing 3 times, let's make this 8 and make this 24. And that would work. Now, you take any 2 sides, it's going to be more than the third side. These 2 sides, is 21 plus 9 is more than 24, 24 plus 9 is more than 21, 9 plus 24 is more than 21. Sum of 2 sides in a given triangle always has to be more than a third side. I made a boo-boo, so we had to fix it. But anyway, we were talking about similar triangles. Similar triangles is where the interior corresponding angles are equal. If the 3 interior angles are equal, the 2 triangles are equal. Or if the 3 sides, if we know that 3 sides of this triangle are proportional to the 3 corresponding sides in the other triangle, then the 2 triangles are said to be similar. Now let's do the problem. Let's do the problem. Now that we understand it, the problem is very straightforward, very simple. Problem number 8. Here's what's going on. We have a small triangle here, which is called P, Q, and R, and then we have a large triangle which is N, O, P. And we know that this side is 24. We are told that Q to R is 24. We know that this is a right angle, this is a right angle, and we know that this is 10 and this is 40. In other words, the whole thing from here to here, N to P is 50. That's what we are told. Here, the triangle NOP, the big triangle, and the triangle PQR, the small triangle, are similar. They are similar triangles. Why are they similar? Well, let's find out why. First of all, this angle is equal to that angle. This angle is shared by 2. This angle, angle P is shared. Well, if it's shared, then of course that angle is equal for both the triangle, because that angle P belongs to the small triangle, and that angle P also belongs to the large triangle. So that is shared. So that angle is equal for both triangles. These two are 90. Well, if these are 90 and that's shared, then whatever is left from 180 must be this guy, which has to be same. This has to be same as this guy, because this is simply 180 minus 90 minus, let's call it what should we call this angle? Let's give it a name. I was going to give it a name. Traditionally in mathematics, the unknown angles are represented with the Greek letter theta, but I don't want to freak you out, so I won't do that. Let's call it angle P, the small p. So this is not, if this is 90 and this is angle P, this is 180 minus 90 minus P, which is same as this guy, 180 minus 90 minus P. So all the 3 angles are equal to each other. All the 3 angles in the 2 triangles are equal to each other, which means the two triangles are similar. Which also means that the sides are proportional, which implies that the sides of the 2 triangles are proportional, and that's all we need. That's all we need. So here's what's going on. Okay, pay attention. I'm going to erase this part. This is looking crowded and ugly. We don't have to show it. We just understand it that this angle also has to be equal to that angle. Here's what's going on. We know that there is one bit of information I think I left out. This is 24. This is 40 and this is 24. And then we extend it by 10. This part is 10. This 10 is simply 1/4 of 40. Isn't it? Which means that the bottom part, the base of the triangle, listen carefully, the base of the triangle NOP, is 1/4 more than the base of the triangle PQR. Just put it down here. Base of the triangle NOP is 1/4 more than the base of the triangle PQR, which implies that the height of triangle NOP will also have to be 1/4 more than the height of triangle PQR. So the height of the triangle PQR, is this 24 right here. So this difference that we see here, this difference has to be 1/4. Let's give it a name here. I'm going to call it x here. O to x has to be 1/4 of 24. It has to be quarter more than this height. Since the base is quarter more than the base of the small triangle, therefore the height of the large triangle also has to be 1/4 more than the height of the small triangle. The height of the small triangle is from n to x or q to r, which is 24 we are told. So what is 1/4 of 24? It is 60. Therefore this guy n to o, is simply 24 plus 6 or 30. That's it. That's all. It's 30. Now that's one way of doing it. This is not a very traditional way. This is very sort of unorthodox way of doing it. If you like, I can show it in we can do it in a traditional manner by setting it up as a ratio problem. If you prefer that, we could do that too. So I'm going to give you a chance to do whatever it is that you want to do with it, and I'll do it in a ratio or proportion manner in a second. Just set it up as a ratio. But before I erase it, just in case if you had trouble reading my handwriting, one more time, I'm going to recapitulate. Here, the triangle NOP and the triangle PQR are similar. Why are they similar? Because three angles of both of the triangles are equal. Why are they equal? Because they share this angle, so obviously that's equal for both the triangles. This is 90 and this is 90, so that's equal, which means the third angle must also be equal to each other. Since the three angles are equal, which means the triangles are similar, which means the sides of two triangles, the corresponding sides of the two triangles are proportional to each other. Because they're proportional. And now, since we know that the base of the triangle NOP, base of the triangle is 1/4 more than the base of PQR. PQR is 40. This guy is 50. This guy is 10 more. 10 is 1/4 of 40. So the base of the large triangle is 1/4 more than this guy. Therefore, height of the large triangle has got to be 1/4 more than that guy. The height of the small triangle, 1/4 of 24 is 6. Therefore, this part right here, O to x is 6, and this is 24. Therefore, the whole thing is 30. That's all. Now let's set it up as a proportion problem. Proportional way is probably the more traditional way that most people will set it up as, and that goes something like this. You set up the ratios of the two sides of one triangle and the two sides of the other triangles, because that's what it means to be proportional. That means the ratios has to be same. If you take the ratios of side NP to the side NO, that ratio has to be equal to QP to QR. Let's see what they are. NP. N to P is 50. 10 plus 40 is 50. N to O, where is O? Well, we have there. I'm going to erase all of this thing. We're going to redo it from scratch. N to O. Well, N to O I think is what we want to find. That's our unknown. Let's call it X. N to O, let's call it X. That's our unknown. Q to P, see, on the top we have N to P. N to P, which is the base. So the base of this side, and therefore it's going to be Q to P with the base of the small triangle, which is 40, over Q to R, which is the height of the small triangle, which is 24. So basically we are taking the ratios of the base to the height. This ratio of base to height has to be the same for both triangles. This one is 50 to X and this one is 40 to 24. And we just solve for X. Divide on the cross multiply, so you get, if you cross multiply the equation, you get 40x equals 50 times 24. 50 times 24. Divide both sides by 40. 40 drops out, and x equals, this 0 is going to cancel out if you divide top and bottom by 10. And here I see 24, or here I see 4. 6 4s and 24, so we get 6 times 5, which is 30. There we go. That's it. So that was another different way of doing it. Is that all they're asking, or is there something more? What are the lengths of the side? NO, we just found it. NO is 30. And they are also looking for the length of the side OP. O to P. So let's do that now. Now in triangle NOP, we just found that N to O is 30, which is the height. We also know that N to P is 40, and O to P is the hypotenuse. O to P, which is the unknown, that's the hypotenuse. So we simply apply the Pythagorean theorem and find its answer. So let's call this, since we're calling this thing X, I'm going to call this guy Y, this length from here to here. Let's call it Y. That means, so we got to erase this thing because that was a different method. That was the previous method. So here, Y squared, which is the square of the hypotenuse, must equal the square of this guy and the square of that guy. How much is 50 squared? Well, 50 squared is very easy to figure out. 50 squared is same as 5 times 5, which is 25, and you get put the 2 0, 1 0 and 2 zeros. So it's 2500. And similarly, 3 times 3 is 9, and since it's being squared, you're going to have 2 zeros. 900 plus 2500, 1000 plus a 2500 would have been 3500, so it's 3400. 3400. Which is your Y squared, therefore, and I'm going to write that 3400 as 34 times 100, that's your Y squared, and therefore the Y is going to be the square root of 34 times 100, and of course the square root of 100 is 10, so it comes out, and you're going to get the 10 times 34. There's not much we can do with the square root of 34. Why? Why? Because it's the product of two prime numbers. I don't know if you can recognize that or not. 34, there's not a hell of a lot we can do, because if you divide 34 by 2, how many 2's in a 3? There is 1 2 in a 3. The remaining one goes and joins this guy, becomes 14. How many 2's in a 14? There are 7 2's. So 34 is just 2 times 17. 2 is a prime number, 17 is a prime number. There is not a hell of a lot we can do there. So there is no point in writing it down as 2 times 17. Just leave it as 34. So the answer is Y equals 10 root 34. Y equals 10 times root 34. Oh, sorry, root 34. Times root 34. Or in the exam, if they ask you O to P is approximately how much, if they use the word approximately, then you're going to say it's approximately 60. Because square root of 36 is 6. 6 times 10 is 60. Approximately 60. That's all. That's all there was. That was the end of that problem. I will see you tomorrow on day number 171. Alright? Bye now.